Have your C++ integrated development environment open with a new project ready to start coding. Have a good understanding of pointers before proceeding. First, we will look at what the compiler is doing with objects when they are passed by value, thereby using the copy constructor. Then we will look at what happens when they are passed by reference, which avoids the use of a copy operation. Finally, we will work with dynamic memory and create a copy constructor to manage it. A struct could have been used, with the only difference being that its members are all public by default. In C++, there is little difference between a class and a struct. Here, we will use the destructor to track when an object is destroyed. We will write a custom copy constructor that tracks every time an object is copied. Every time an object is passed by value to a function, the copy constructor is called. Every time an object is returned from a function by value, the copy constructor is called. When we run this program, you will see how many copies of this object are made. Generally, it is bad form to make copies of objects because the copy operation can hamper performance, particularly with objects that contain large amounts of data. The copy count data member should be an integer. As you can see, this is 5 copy operations. If these were objects with large amounts of data, then performance would certainly suffer. Some of the copy operations, like those made by the makeCopies function, are not necessary. Let's pass these objects by reference to see how fewer objects are created and destroyed. Now, that is much more efficient. As you can see, 3 objects were created with copy operations when, before, 5 copy operations were made doing the same thing. Always pass objects by reference when a copy of the data is not necessary. Sometimes, a copy is in order and totally necessary, but most of the time, it is not. Custom copy constructors are necessary when copying objects that dynamically allocate memory using the new operator and then, of course, delete said data with the delete operator. Let's create a new class that uses dynamic memory but without a custom copy constructor to see what happens to the data. Let's run the code and see what happens.
While the program did not crash as it would if this were production code, you can see the ABC data was deleted by the destructor of one of the objects and is not printing. You may think that the solution is not to delete the data, but this would be a memory leak. The solution is a custom copy constructor that allocates new memory and makes a copy of the data. The copy constructor that the compiler made just copied the address that the pointer was pointing to into the copied objects, and then when an object was destroyed, the data was deleted, as it should have been. Because this is C++, memory must be managed, which is not the case for higher-level languages like Java, C#, JavaScript and Visual Basic that automatically delete memory allocated for variables. This is the custom copy constructor. str will be a copy of obj.str. This line of code is a little trick to make the compiler think it is copying an integer. This makes a copy of 4 bytes at once. As you can see, ABC has not been deleted and it printed correctly as expected. You do not need a custom copy constructor when the data members of the class have their own copy constructor. The string class has its own copy constructor. Let's use a string object instead, which allocates its own dynamic memory. Make sure the string header file is included. We don't need this custom copy constructor. Return a reference to the string object, as this is more efficient. Otherwise, a copy of the object must be made, which is not efficient. As you can see, the output looks and works the same without a custom copy constructor for our class thanks to the string class which has its own. Please subscribe and like this video to see more videos like it.